All right, so now we have example 2. And this one we're going to go ahead and do it with Desmos again. And then the next video we're going to do the same thing with the RTI 84 so that we can have both of them. All right, so here we're looking at x cubed plus x squared is less than or equal to 4x plus 4. So with that, we're saying, okay, when x cubed plus x squared is less than or equal to 4x plus 4, in other words, where we're looking for where 4x plus 4 So we're looking at where the domain allows 4x plus 4 to be greater than or equal to x cubed plus x squared. To put that in better terms, we're pretty much saying where the x values where 4x plus 4 is higher than, greater than, higher than, the numbers are higher than, or equal to x cubed plus x squared. So when we look at our graph of this, we're talking about, okay, where is it that x cubed plus x squared is below 4x plus 4? So I'm going to write that too. So that way we can have all the different sayings here so we can understand that, okay, that's what we're trying to say. Right, so that's what we're looking for. So when we look at our graph here, we're going to again do a Desmos here. We're going to find those intervals where the x cubed plus x squared is below 4x plus 4. Or you can put it backwards and say, okay, where is 4x plus 4 above x cubed plus x squared? Either way. All right, so let's go and pull Desmos up. And let's go ahead and actually deal with that part. Let's move this over here. Right. So we have that already. Hey, look at that, look at that. All right, moving that over here. All right, so here we have the function x cubed plus x squared, and we have the other function 4x plus 4. So we know the 4x plus 4 is the purple function. We know x cubed plus x squared is the green function. We're trying to find out where is it greater than or equal to. So I'm going to get rid of that part really quick. We're going to pull it in a little bit, just a little bit. Right, let's widen it out. There we go. That looks better. All right, so we're taking a look at the points first off that are intersecting. So we know it intersects here, here, and here. So let's go to let's write that down too. So our points of intersection are where the functions equal each other. And you learned that in your previous math classes. So here, our points of intersection are we have -2, -4. So we know that point. We have the point, oops, we didn't do the right point there. Should be right here. -1, 0. Oh, it's not typing. Let's do that. Type it in here. -1, 0. And then we have 2, 12. All right, so we have those points there of where the functions intersect. So that's going to be part of our answers because that's where they intersect. But we need to find, okay, those parts where the purple line is above the green line. All right, so with that, let's go and take a look at it. So here again, here, here, and here. So we know, my finger back up here. So we know this portion here. Where's my pen? There it is. So we know this portion right here. Well, let's not use green. Let's use something else. Let's use black. So we know this portion, sorry, right here, that is greater than, that's higher than the green line. So we know it's from our domain, our x values, where the function is higher or equal to. It's from -infinity to -2. At -2 is where it's equal to. So we go ahead and put that there because we're trying to find greater than or equal to. We also, well, from this point here to from -2 to -1, the green function is higher, so we don't use that. All right, and then from the rest of it here, from -1 to +2, it actually is again above the purple line's above the green line. So again, -1 to 2. And again, we put the brackets there because it is equal to on those spots. After that, the green line's above it pretty much for the rest of the time because it goes exponentially, not exponentially, but cubically, it goes up higher than it does, faster than it does with the linear function. All right, now, another good thing that we talked about in class and we saw in class, and I didn't even think about this until like students said it, we can actually put this all together in one line. But with that, you have to make sure that you understand what we're looking for. So we have these two going on, but again, you have to understand what's being shown here. So we put the whole equation, the whole inequality in, sorry. So x cubed plus x squared is less than or equal to 4x plus 4. And let's go back up top to again so we can make sure we have everything right. See, same thing. So we put it directly into the calculator, into the Desmos calculator. But now we have to figure out, okay, well, what is going on? What does this mean? Like, again, it's not just about getting like something on the graph. You have to understand what does that really mean when we get something on the graph like this. So from what we just said, for our answer here, we said it's from -infinity to -2. So this showed us everything from -infinity, whatever this last part is. And actually, let me do this. Let me drag it. As you can see, if I drag it and I keep pulling it, it's going on forever on that right side, the left side, sorry. So here, that means we're talking about infinity. So it's going from -infinity to, it goes from -infinity to -2. Let me pull this back out, sorry about that. Go back home. All right, so -infinity to -2 to match up. So from all of this, oh, stop it, there you go. Where's my pen? All of this, there we go, finally, to -2 right there. It's -2. And then from -1 all the way until we get to 2. And we can see that that actually is the numbers that we're talking about really quick. Let's pull it in. And the great thing about Desmos is you can pull things in really quick. So again, from -1 to 2, and then from -infinity all the way to -2. So again, it's two ways of looking at it. And we still have the right answer. There we go.